Hello students, in the last video lecture we talk about the classification of the partial differential equation and some example of the linear PDE we talk about. So today we start with initial value problem. We have to find the solution of the homogeneous linear initial value problem, which is ut plus b dot du is equal to 0 in Rn cross 0 to infinity. And what is the initial condition is that u is equal to g on Rn cross t equal to 0. That means what is the, if you say u is the solution of this equation, u means u of xt. Okay, u of xt where x belongs to Rn and t belongs to 0 to infinity, and u is equal to g is the initial condition. What does it mean? At t equal to 0. So initial means at t equal to 0. So you say u at x comma 0, that will be equal to g of x. Okay, so this function g is the known function actually. So g is the function from r raised to power n to r, okay, which is known. So it is given here g Rn to r is known, and you have to find out the value of u. This is a known function actually, u. Here this b is also belongs to Rn, is a fixed factor. Now you have to find out the solution of this homogeneous linear initial value problem. So what do you do now? First of all, we suppose that xt be any point in Rn cross 0 to infinity, and let u be the solution of the given PDE. And we define that z, a function from r to r, by z of s is equal to u of x plus sb comma t plus s for s belongs to r. Okay, as we defined in the last video lecture we talk about. So in the similar manner we are defining the same z as a function such that z of s is equal to this one, right? So now we find out the derivative of z with respect to s. So if you find out the derivative in the same manner as we done in the previous lecture, so that is z dot s will be equal to d of u into b plus ut of this. Okay, but u is the solution of the given initial value problem. So if u is the solution of that, so that means you will say that ut plus b into du, that will be equal to 0. So you say that z dot s will be equal to 0, right? If z dot s will be equal to 0, so integrate with respect to s, we will say that zs will be equal to constant. So z will be the constant function of s. Okay, if z is a constant function of s, but what is zs? Zs is equal to u of xt, right? So that means if z is equal to u, so you will say that if z is constant, so that u will be constant. So u will be constant on which? So u will be constant on the line passing through the point xt with the direction b1. Okay, and this line, you will say that which line? This line can be represented parametrically by xt plus s into b1. Okay, or you can say that if you rewrite it, it will be x plus sb comma t plus s, right? It will be like this. So in this way we will say u will be constant on the line passing through this, and this line is parametrically represented by this, where s is any real number. Okay, now we say this line will hit the plane. Suppose the plane is denoted by gamma and the plane is Rn cross t equal to 0. So this is the plane. So when this line will hit this plane when, so this at this plane t is equal to 0, right? So that means if some point in Rn into 0, t is 0 here, so that means this point from Rn, so this should be 0 actually. If this should be 0, so that means s plus t will be equal to 0. If s plus t will be equal to 0, so you will say that s will be equal to minus t. Okay, only in that case that becomes 0, right? If s is equal to minus t, so this value becomes x minus tb, right? So you will say that the line when it will hit this plane, so this becomes x minus tb comma 0, right? When this line hit the plane gamma, so you will say that when this line hit the plane gamma, at that point with the point will be x minus tb comma 0, right? So now you got that point, but u is given here constant along the line, as in the previous lecture we have talked about. So that means for the transport equation, this is ut plus b dot du equal to 0. So is the transport equation. For that u was the constant along the line passing through the xt and with the direction b1. So if u was a constant, so you will say that u is constant and u of x minus tb comma 0 will be equal to what? Because हमें इनिशियल कंडीशन गिवन है कि u will be equal to what? u of x comma 0 will be equal to g of x. So right, u of x minus tb comma 0 will be equal to g of x minus tb. So that's why u of x minus tb comma 0 equal to g of x minus tb. Okay, if u is constant, so you will say that u of x minus tb is equal to g some constant, or you will say that u of xt will be equal to constant, or you can say that this will be equal to u of xt, right? Because both of u will be equal to the constant, so you can deduce that that will be equal to constant, that will be equal to the same constant. So that means you will say that both are equal. So in place of this one you can say that u of xt. Okay, so u of xt will be equal to g of x minus tb, right? So that means we got the solution. U of xt is the solution of the given homogeneous initial value problem. So that will be the solution of the homogeneous linear initial value problem, where x is belongs to R and t is greater than or equal to 0, right? So that will be the solution, right? So if we have the equation means homogeneous linear initial value problem, so that will be solution. Now we take the converse. If this is the solution, so that means condition will be satisfied. So you have to, which condition will be satisfied? Ut plus bdu will be equal to 0 and u will be equal to g on Rn cross t equal to 0, right? So this thing you have to prove now. So we assume that, so for this, if g is, we take it here, g is one time continuously differentiable. Okay, g is one time differentiable and u defined by 2 is the solution of the equation 1. Okay, so that means we suppose that जो ये है, we suppose that कि this u is the solution of the given equation 1 and this g is one time differentiable. So if g is one time differentiable, so you will say that u of xt will be equal to g of x minus tb. This is the solution, we suppose, solution of the equation 1. So if we find out the derivative with respect to t, so that will be ut. So what will be the derivative of this with respect to t? So it will say that that will be dg d of g, right? Capital D of g into derivative of this thing again with respect to t, that will be minus b, right? So it will be into minus b. So it will be ut. Now you find out du. So when you find out the du, so d of u will be equal to d of g. So that will be d of g, right? So now we got the value of the ut and du, but we have the equation ut plus b du we want, b into du. So if we want ut plus b into du, so that will be equal to what? That will be equal to, ut will be equal to minus b into dg, and that is b into du. Du is dg here, so b into dg. So minus b dg plus b dg, that will be cancelled out and that becomes 0. So that we got that equation ut plus b du equal to 0, right. So that means this will satisfy this equation, and also we check that whether the initial condition is satisfied. So ये तो check हो गया, this u is the solution of this equation. Now for the initial condition take t equal to 0. So now we take t equal to 0. So what was the solution? That is the solution. So you take t equal to 0 when t is 0, it will be u of x 0, and that will be equal to g of x minus 0. It will be g of x. Okay, so that becomes the initial condition, u of x 0 equal to gx in Rn, or you can say that in Rn cross t equal to 0, right. So in this way you can say. Okay, so that means if this is the solution, so that condition will be satisfied, or in the another word you can say that if this is the PD ut plus bdu equal to 0 in Rn cross 0 to infinity and ux 0 equal to gx in Rn cross t equal to 0, then that will be solution. Okay, so now we got the if and only if case for the homogeneous linear initial value problem. Now the next one is non-homogeneous initial value problem. So which is non-homogeneous transfer problem, you can say that. So for the non-homogeneous, that means the right hand side is not 0 actually. So what is this one? This is ut plus b into du is not equal to 0, that is equal to f. Okay, where f is some function, non-function, right. So you have to find the solution of this non-homogeneous transport problem. Ut plus b into du will be equal to f in Rn cross 0 to infinity, and u will be equal to g. This is the initial condition actually. U will be equal to g on Rn cross t equal to 0. Okay, so यहाँ पर जो ये f है and g है, these are the known function. So f is from Rn to r, sorry, Rn cross 0 to infinity to r, and g is from Rn to r. These are the known functions, and b is some fixed vector in Rn, right. So for this you have to find out the solution. So in the similar manner as you done in the previous proof, let x to be any point in Rn cross 0 to infinity, and let u be the solution of the given partial differential equation. Okay, now we define a function z from R to R by z of s will be equal to u of x plus sb comma t plus s for some s belongs to R. Okay, now in the similar manner as we done in the previous two proofs, so z dot s, if you differentiate with respect to s, that will be given by z dot s will be b dot du plus ut of this one. Okay, that becomes ut plus b dot du, right. But you know that if u is the solution of the given equation 1, then ut plus b du will be equal to f. So that will be equal to f of xt, but here is this one are the variables. So f of x plus sb comma t plus s, right. So that will be equal to this one. So you got z dot s will be equal to this one. Okay, now what we do, you just take the integration with respect to s both side within the limit minus t to 0. Okay, so take the integration. So its integration with respect to x will be zs. So you take the its integration is zs, sorry. So its integration will be zs minus t to 0, and that will be equal to, its integration will be equal to integration of f of x plus bs comma t plus s with respect to s within the limit minus t to 0, right. So it will be z0 minus z of minus t, and that will be equal to this one. Now you know value of the zs, value of zs, as you know, what was value of zs? Zs, as we define here, Z of S will be equal to U of x plus Bs and T plus S, right? Right, T plus S. So when you write down here Z 0, so S is 0 here. So when you take S is 0, that will be U of x comma T. So U of x comma T minus Z of minus T. That means in place of S you have to minus T. In place of S minus T, so that becomes 0, and minus T, that becomes x minus Bt. So U of x minus Bt comma 0. So U of x minus Bt comma 0. Okay, and right hand side is same, right? So what you have to do now, just for solving this, we do the supposition. Let us say T plus S will be equal to some another variable S dash. So S will be equal to S dash minus T and ds will be equal to ds dash. Obviously we change the limits also. So if S is minus T, so S dash becomes 0. If S is 0, so S dash becomes T. So the limits becomes 0 to T, right? So f of this value becomes S dash, and ds will be equal to ds dash. Okay, so value of the S, just you have to place the value of S. Value of S is S dash minus T. This is the value of S. So you place over here x plus S dash minus T into B. Okay, ds dash. Now you write down U of xt, and what is the value of this one? Since the value is given here, U x comma 0 is equal to Gx. So U of x minus Tb comma 0 is equal to G of x minus Tb. So we write down its value, initial value, condition. By using the initial condition, you write down its value. So U of xt minus G of x minus Tb will be equal to this thing, right? So what will be the value of U xt? Just you transfer this thing to the right hand side. So you got U of xt will be equal to G of x minus Tb plus limit 0 to T f of this ds dash. Okay, now here is S dash minus T B comma S dash ds dash. Okay, you can rename the variable also. Okay, you can write in place of S dash, you can write S also. So it will be f of x plus S minus T into B comma S ds, right? So this will be the solution of the non-homogeneous initial value problem. Okay, so in this way we got the required solution. Now we move to the another problem, that is the Laplace equation. So the Laplace equation is given by delta of u will be equal to 0. What is the delta of u? Delta of u is nothing but the summation is varying from I equal to 1 to n u of xi equal to 0. Okay, so this is your Laplace equation. Here x belongs to u, which is unknown function. Unknown function is small u here. Okay, and this small u is from u bar to r. Okay, where capital U is the subset of Rn, is the open subset of Rn. Now the harmonic equation. So what will be the harmonic, not a equation, harmonic function. So it's by mistake it is written over here is harmonic function. So what will be the harmonic function? So a two-time differentiable function u satisfying the Laplace equation is called the harmonic function. So कोई भी जो टू टाइम डिफरेंशिएबल फंक्शन है जो लाप्लास इक्वेशन को सेटिस्फाई करता है, दैट इज नोन एज द हार्मोनिक फंक्शन. Okay, so now we derive the solution of the Laplace equation. So let us move to the solution of the Laplace equation. What is the Laplace equation here? Delta of u equal to 0 in Rn, or you can say the summation of I equal to 1 to n u xi equal to 0, where capital U is a subset of Rn which is open, and unknown function u is from u bar to r. Okay, now it is advisable to search for the radial solution. The radial solution is a function of r. So function of r means, what is the r here? R is mod s actually. Okay, So radial solution we want to find out. So radial solution means function of r. R will be mod x. Therefore, we may consider that for the radial solution, we may consider that जो ux है, ux is the solution of the Laplace equation as ux equal to vr. Okay, हमने रेडियल सॉल्यूशन के फॉर्म में निकालना सॉल्यूशन. So that's why we take ux equal to vr. Where what is this r? R is mod x. And what is mod x? Mod x is x1 square plus x2 square plus xn square under the root. Okay, and v is to be selected such that delta of u equal to 0 holds. Okay, जो भी ये हमने फंक्शन यू एक्स इक्वल टू वी आर लिया है, ये इसी वे में लेना है सच दैट जो ये u है ये सेटिस्फाई करे लाप्लास इक्वेशन को. ओके, नाउ सिंस r is given here, this one, so no need to worry now. Just we have to find the value of u xi and summation I equal to 1 to n. This value we have to find out. So we have ux equal to vr. So first of all you have to find out the partial derivative of u with respect to xi. So you take the partial derivative. Now this is a function of r. If this is a function of r, so you apply the product rule. No, sorry, not a product rule. It's a, you can say, chain rule. It will be curl v over curl r and partial derivative of r with respect to xi. So when you find out its partial derivative with respect to xi, so you know r is there. So if you find out its partial derivative with respect to xi, it will be half of x1 square plus x2 square plus xn square power minus half into 2xi. Okay, derivative with respect to xi, so it is 2xi. So 2 will be cancelled out. It will be xi upon root of x1 square plus x2 plus xn square. But root of this term is mod of r. Okay, so mod of x. So it will be xi divided by mod of x. But mod of x is r. So it will be xi over r. Right. This value is actually mod of x and mod of x is r. So this value is xi over r. So that means we got the value of curl r over curl xi is equal to xi upon r. So we place this value over here. So u curl u over curl xi will be equal to, it will be v dash r, curl v over curl r is v dash r into xi over r. Okay. Now again we take the partial derivative with respect to xi both sides. So when you take the partial derivative with respect to xi, you can check here. It will be curl square u over curl xi square. Okay, that means it will be equal to curl by curl xi of this term to the right hand side. Okay, so what you have to do now, just apply the product rule over here. Partial derivative of, just keep it as it is. This one is as it is, so partial derivative of this, so it will be v double dash r into curl r over curl xi, right, plus now v dash r as it is, v dash r as it is, so curl by curl xi of xi over r, right. Similarly, just you open it and you place it value, curl r over curl xi, इसकी वैल्यू क्या आई थी आपके पास, xi upon r. So place its value will be xi upon r. Okay, so this value as it is, this value as it is here. Now further this value is as it is here. Now you have to apply that product rule over here. 1 by r as it is, xi derivative will be 1 minus xi as it is, 1 by r derivative will be minus 1 by r square into curl r over curl xi, but its value is xi upon r. Again we place its value further. So when you place its value, you will get that. So you will get that when you place its value, it will be this one. So after solving these terms, we get this one. Alright. Now when you take its product inside, so that will got v double dash r xi by r square, it will be xi square by r square minus v dash r upon into xi square by r cube plus v dash r upon r. Okay, so its value is u xi we got, हमारे पास ये आ गया वैल्यू. For what you have to do now, just you have to take the summation both side, दोनों तरफ समेशन ले लीजिए, इस सारे का समेशन ले लीजिए, I equal to 1 to n, right? I is varying from 1 to n, so n टर्म्स तक के लिए समेशन ले लेते हैं. So when you take the summation, so now you can check that summation both side, it will be this one. So when you take the summation, so summation of this term plus summation of this term plus summation of this term, okay? So when you take the summation of this term, so summation is over I, so you can take this term and this term outside the summation, v double dash r divided by r square is outside, and summation of xi square, I is varying from 1 to n, minus v dash r upon r cube is outside, summation of xi square, plus v dash r upon r is outside, summation of 1, okay? So summation of xi square, what does it mean? That means x1 square plus x2 square plus xn square, that will be equal to r square, right? So we place its value is r square, its value is r square, and summation of 1 n times, that will be n, right? So we place it value, r square cancel, this r square cancel, 1 r will be left here, and that is n, right? So we got this value. In such a way, we get delta of u, that the left hand side is actually the summation of curl square u over curl xi square. What is this one? That is delta of u, okay, Laplacian of u. So that will be equal to this one. We got this value. So here, if you take this term is common here, so that will be v dash r upon r is common, and that becomes n minus 1, right? N minus 1 into this one. So v double dash r plus n minus 1 into v dash r by r, right? But this delta of u, since this is the Laplace equation, so delta of u will be equal to 0. So if this is equal to 0, so that value will be equal to 0. That value will be equal to 0. If this value will be equal to 0, so you are going to solve it. So you will say that delta of u will be equal to 0 if and only if right hand side will be equal to 0. Okay. So if this will be equal to 0, so you will say that v double dash r will be equal to 1 minus n into v dash r upon r. So again, v double dash r divided by v dash r will be equal to 1 minus r by r. Now you have to take the integration both side with respect to r. So when you take the integration, you can check it will be, its derivative is present in the numerator, so it will be log of v dash r, right? And it will be 1 minus n into log r plus constant of integration, that is say log a, okay? And it can be written as log of r raised to power 1 minus n plus log a, okay? And that can be written like this, log will be cancelled out, and we get v dash r will be equal to a into r raised to power 1 minus n, okay? Now again, v dash r is dv by dr, so we write it, and again separate the variable, dv will be equal to a into r raised to power 1 minus n into dr, right? Now you take the integration again, so it will be, its integration will be v, and it can be written as a upon r raised to power n minus 1 into dr, okay? If we take, now you have to find out the integration, remember, if we take n is equal to 2, sorry, this is n equal to 2, if n is equal to 2, so it will be a upon r, so a upon r integration will be a into 1 by r integration will be log r, so it will be a log r plus some constant c, okay? And if n is greater than equal to 3, okay, 2 के लिए तो हमने निकाल दिया, अगर greater than equal to 3 है n की वैल्यू, so that will be n minus 1, right? So it will be a that come into numerator, and it becomes r raised to power 1 minus n, right? So when you take its integration, it will be r raised to power 2 minus n divided by 2 minus n, right? So a upon 2 minus n and r raised to power 2 minus n. Again we come to the denominator, r raised to power n minus 2 it becomes, and plus some constant of integration for n greater than equal to 3, okay? So in this way we get the solution. So that will be the solution. In the start, we suppose that u x will be equal to vr, ये हमने solution निकालना था, and vr we got, this is vr actually, okay? So this is our required solution. right, of the Laplace equation. So now in the another way we can say that if r is positive, so we can say that Vr will be equal to this one. Okay, जो ये आपका constant है, this term you say this, it is some another constant b, so it will be a log r plus c for n equal to 2 and b by r raised to power n minus 2 plus c if n is greater than equal to 3. So that will be the solution of the Laplace equation. Okay, now there is a definition. The function, it is capital phi. Capital phi x is defined as minus 1 by 2 pi into log of mod x if n is equal to 2, and capital phi x will be equal to 1 by n into n minus 2 into alpha n into 1 upon mod x power n minus 2 if n is greater than equal to 3. This is defined for all x belongs to Rn and x is not equal to 0. This is the fundamental solution of the Laplace equation. Okay, so remember this definition throughout the chapter, that will be useful, or throughout the whole 4 units, that will be useful. Okay, so that capital phi x, that we will use to denote the fundamental solution of the Laplace equation. Okay, so the next topic we will discuss in the next class. Thank you very much, students.